Okay, welcome back. So in the previous video, we talked about how to create data frames and how to preview data frames. So now let's talk about subsetting data frames. Previously, we talked about subsetting vectors, and subsetting data frames is actually very similar to subsetting vectors. But you can see the difference between data frames and vectors is that this is a vector, right? A vector has only a column, one column, multiple rows. Um, but data frames have multiple columns and multiple rows. That suggests when we subset data frames, we must supply um, row information and cell information. So let's start with subsetting columns or subsetting variables. So to subset any variables, we use the general sort of structure as we start with the name of the data frame. In this case, df1. We don't have to quote, wrap it with quotes. Just df1, the name of the data frame, and then we use the square bracket approach as we did with subsetting vectors. Because we want to subset columns, entire columns, so we can leave actually um, the row position as a blank and then comma. Okay, so later on we'll see what will happen if we enter some number here, but now because our goal is to subset the entire column, any entire column, so we can leave the row position blank. And when we leave the row position blank, we're telling R that we want all rows in a particular column. Let's say we want a second column. Okay, so in this command tells R I want every element, well, every row in the second column. So we can hit Control Enter. Now this is actually the H vector, right? So yes, now R becomes lazy. It converts back to the representation of vectors as a row. But now you can see sort of the original. Well, if we print df1 again, right? This is the actual vector. Now R just because now becomes a separate individual vector are represented as rows. Okay, but they're the same. Um, this is subsetting by position, right? The second column. Well, you can also subset by vector name, and you can subset multiple vectors by their names too. So you can say, well, I want to subset the GPA, well, the H column and the GPA column. Yeah. So you need to concatenate them into a vector, and you're telling R to subset df1, your data frame, by this vector, which consists of two sort of variable names. Now R maintains its representation of vectors as columns. So you have H and GPA, and it keeps the row indices as well. Of course, you can subset multiple columns using positions. That's just fine. So let's say I want to subset the first this time and the third. Okay, so Control Enter. There we go. Names and GPA. Okay. An alternative, way to subset entire column is use the dollar sign. So let's say if I want to subset the entire or select the entire column of age. So you see here once you enter the dollar sign, now RStudio will give you three options because you only have three vector column vectors. So let's say I want GPA. Okay, so now Control Enter, you will have the entire column of GPA. So this is sort of easier to type, right? Compared to type, a pair of brackets, a space, comma, and then the indices of the columns. Now you just need to type a dollar sign and then the name of the vector, which is easier and faster. And it's useful in many tasks. For example, if you want to compute the mean of GPA in our data set, you say, well, I want the mean of the GPA column um, of our data set. So df1 GPA. Okay. Now you get the average GPA in our sample is 3.159. For example, we'll find out, okay, so how many elements are there um, there are in our um, age vector? Sorry, age. Okay, there are 10. Okay. Another very useful, well, useful use, another use of the dollar sign subsetting approach is to create plots. Okay, so let's say, because in our data frame we have what two numeric vectors, and with two numeric vectors, we sort of know we can compute correlations, we can visualize correlations to see whether or not students' age is in any way related to their GPA, right? Well, for now we don't have to compute correlations because we haven't learned about computing correlations, but very intuitively we know, we understand a plot, right? That visualize the relationship between age and GPA. So let's actually learn briefly how to plot the correlation between two variables. It's actually not very difficult with R. So a generic function is to plot. Okay. So we can specify the content of this plot function. We start by specifying the x variable, or the variable that would appear at the x-axis. So let's say it's going to be what? Sorry, df1. Let's put age as our x variable, or the variable at the x-axis. There's no reason. That's just my choice. And let's put y, as our df1 as our y variable, or the variable that would appear in or along the y-axis. So let's hit Control Enter and see what happens. You see here we have actually a very quick and dirty quick plot of the data points based on age and GPA. So there's some plots here, some dots here, some dots here, and some dots here. So you can quickly eyeball, right? So there doesn't seem to be any correlation between age and GPA, because the best fitting line is gonna be this guy here, right? Well, you can actually add a best fitting line, so it's gonna be AB line. It's gonna be a linear model, and regress GPA on GPA on age. Does it work? Works. Okay. So well, we'll explain what these means in a minute. Well, in future art sessions. But you see, the best fitting line is actually a horizontal line, so there's no correlation. So this plot looks pretty ugly, right? The labels don't make much sense. The dollar signs around, and they're pure black and white, so they're not pretty looking. We can make it prettier by adding more elements to the plot function. So we can end the first line with a comma and then continue, right, in the second line. So what can we specify here is, for example, the color of the dots. Well, let's specify the color of the dots. So we can make it what, blue, for example. Okay. We can also make the dots solid. So 16 here simply means, in our library 16, um, PCH, or point style, essentially means solid. So that's why the number is here. And then CX is the size of the dots. The default is 1. So this default, but I want the dots to be a bit bigger, so maybe zero point 0.3 bigger. Um, okay, let's switch to a new line. I want a main title. So I want a main title. I will say correlation between what students' age and GPA. I also want the labels for the x and y axis, better or clearer. So you can say x label is what, student's age, and then the y label is student's GPA. Okay, that's pretty much it. Let's see. Let's run the entire thing. Right, highlight all the lines, and then see what happens. Run. Fantastic. Right. Now we have the appropriate X labels, Y labels, and then the main title, and all the dots are blue. Well, you can change to black if you don't like it. Right, black. Run it again. Wait. Now they're black. Okay. And then if you want the line, there's the line. Okay. It doesn't look very straight, but when you print it out on a piece of paper, it's actually straight. Okay. Good. That's our first visualization. Later on, we'll see more plots. R has very powerful, graphic functions. So play with it, and we'll learn more about plotting in the future R sessions. Okay, so far we have been, subsetting columns. What about subsetting rows? Subsetting rows is very easy once we learn about how to subset columns. So for example, if we want to subset the entire fourth row of our df1, then just 4 comma. You don't actually need a space here as long as you have a comma, but I always put a space to just remind me that, I'm leaving the column position blank so that I want all the columns of the fourth row. Okay. Yep, that's all the columns, all 3 variables for the fourth row, which happens to be the observation on Derek. You can, of course, subset multiple columns. Yeah, so I want the first, the 6th, and the 9th. But don't forget to put a column here. Okay. Whether space or not, that's up to you. I usually want a space just to increase readability and just remind me that I want all columns for these 3 rows. Yeah, so Andrew's row, Frank's row, and Ivan's row. Okay. What if I want consecutive rows? Yeah, so I can say, well, I want row 6 to row 9. So df, right? We actually have seen how to, generate a sequence, a numeric sequence, right? So just, 6 colon 9 and comma. So whenever you use the colon to generate a sequence of values, you don't need concatenation. R recognize this as a vector, right? So just enter disclosure. Oh, I forgot a 1 here. No wonder. Okay, so there we go. The 6th, the 7th, the 8th, and the 9th row. Okay, so so far we've been subsetting entire columns and entire rows. What if you want very specific a value is cell? Then you can imagine you can just enter. For example, I want the value at intersection of row 6 and column 3. Let's say row 7. Let's try something new. So this is gonna give us the value at row 7 and column 3. Well, let's reprint df1 to see what it is, and let's make a prediction, right? So if the syntax is correct, then it should give us the value at the intersection of row 7 and column 3. That will be George's GPA 2.14. So we hit Control Enter. It is indeed 2.14. Okay. Now you can expand or adapt this syntax to select multiple rows and columns. So for example, you can easily access or select the first, fourth, well, the values at the intersection of the first, fourth, fifth row and the first and third column. Okay, so let's see what we should be able to get, right? So intersection of the first, the fourth, and the fifth rows, and the first and third columns. So you should give us Andrew 3.40, Derek 2.87, and Emily 2.91. Okay, see if we're correct. Exactly. Andrew, Derek, and Emily 3.40, 2.87, and 2.91. Okay, so this is the subset where select multiple rows and multiple columns. Now, a very important type of subsetting is what we call conditional subsetting. So, conditional subsetting. Conditional subsetting is the idea of selecting elements that meet certain criteria. And this is very useful. For example, you might want to analyze participants belonging to a certain age group, right? All participants between 30 and 40 years old. You may want to analyze, males only, right? And for now, ignoring all the females, or you can analyze all participants from New Jersey, right, from a certain region. So in all those examples we just mentioned, you essentially want to subset rows, right, participants, by certain conditions applied to some screening variables, right? You want participants belonging to certain age groups, you want participants belonging to a certain sex group, of a certain sex, and want participants from a certain region. So these are examples of conditional subsetting. All right, let's see examples that will always make things clearer. So from df1, let's say I want all the cases, all the rows, right? All participants who are exactly 18 years old. Okay, so you put this screening criteria at the row position because you're subsetting rows, right? You're subsetting participants that meet this particular condition. So that's why the criterion will appear at the row position, and you want all the you might want all the vectors and columns, so you leave this blank. And remember that you need two equal signs, and don't need to wrap the age with quotes. So let's hit Control Enter. There we go. We have two actually students in our sample that are exactly 18 years old, and then R will print them out for you. You can also say I don't want students who are 18 years old, right? You can select all students who are not 18 years old. So to do that, df1, and then you will say, well, I mean, let's print, the this will give us students who are exactly 18 years old, but you don't want these students. You want students who are not 18 years old. So you will you will you will put a exclamation mark um, ahead of or before this criteria. So exclamation mark in R and many other programming languages means negation, right? So this is students who are exactly 18 years old. Then you put an exclamation mark ahead of it. Then you say, well, anyone who's not 18 years old. Okay. Control Enter. Now you have all the students who are not 18 years old. Now you can say one student, whose GPA is at most 3.0. Yeah, that is smaller or equal to 3.0, right? That's at most, right? So you can be equal to 3.0 and you can be smaller than that. So again, don't forget the comma to indicate that I want rows. Okay, so these are all the students whose GPA does not exceed 3.0. You can select all participants, students in this case, whose GPA is, for example, DF1, GPA. That's at least 2.88, right? So that means it's gonna be larger than or equal to 2.88, but smaller than 3.5. So in this case, you want the rows to meet two criteria at the same time. So it's going to be and here, and then GPA smaller than 3.5. Okay. Now you have all the participants' cases that satisfy this criteria. You can, of course, subset by multiple different conditions. So this is multiple conditions, but they're they're same variable. But you can say, what if I want, the rows or cases who are first very young, so age is smaller than 20, but at the same time, I want good students, so GPA that's at least 3.0. Yeah. Turns out Kathy is the only person that meets your criteria. Okay. All right. So this is going to be very useful, as I said, because sometimes you want to be very focused on some portion of your data, and this will allow you to subset that portion of data based on certain conditions. Okay. In the next video, we'll be talking about how to sort data frames, how to delete and adding columns and rows. Okay, see you very soon.